Please like and share my videos, and please subscribe my channel if you have not already subscribed. 12 questions were given from the topic Applications of Derivatives from the chapter Differential Calculus in the JEE Main Examination held in January 2024 session. In this video, we discuss the first 4 questions. This question has appeared in the JEE Main Exam held on 27th January 2024 in the first shift. The given question is, let for a differentiable function f from the open interval 0 to infinity to r, where r is the set of real numbers, f of x minus f of y is greater than or equal to log of x by y to the base e plus x minus y for all xy belongs to 0 to infinity. That is, your function f satisfies this inequality for all xy belongs to the open interval 0 to infinity. Then sigma n is equal to 1 to 20 of f prime of 1 by n square is equal to, right. Let's now discuss the solution of the problem in detail. We have the given inequality which is true for all xy belongs to 0 to infinity. So log of x by y to the base e is log of x minus log of y. It can be written. Agreed. We deal with the 2 cases. In the first case, let x greater than y. Then in that case, x minus y greater than 0. Therefore, 1 by x minus y is positive. Therefore, you are multiplying throughout by 1 by x minus y. Then you will get f of x minus f of y by x minus y greater than or equal to the inequality. The inequality is not get disturbed because we are multiplying by a positive quantity, and that is ln of x minus ln of y by x minus y plus x minus y by x minus y, that is 1. Agreed. Now take as y tends to x. So x greater than y means y less than x. Y tends to x means y tends to x from left. So that is the limit y tends to x of f of x minus f of y by x minus y greater than or equal to limit y tends to x of ln of x minus ln of y by x minus y plus 1. For 1, there is no need of taking limit because it is a constant. Right. As y tends to x greater than y means y less than x. Y tends to x means y tends to x from left. Therefore, this is, and it is a differentiable function. Therefore, the limit exists, and the value is a derivative. So that is the left hand derivative. F prime of x minus is greater than or equal to 1 by x. This is the derivative of ln x, 1 by x plus 1. Let's call this as the inequality 2. Consider now second case. Let x less than y. Then x less than y means x minus y is negative. Therefore, 1 by x minus y is negative. So multiply by 1 by x minus y. Then you will get f of x minus f of y by x minus y. And the inequalities get reversed. That is, it will become less than or equal to y because 1 by x minus y is negative. Remember, ln of x minus ln of y by x minus y plus 1. Right. So, x less than y, y tends to x means y tends to x from right. Therefore, when you take the limit, limit y tends to x of f of x minus f of y by x minus y will be the right hand derivative of f of x at x, because f is the differentiable function. So this will imply f prime x plus, that is the right hand derivative, less than or equal to 1 by x plus 1. Let's call this as the inequality 3. Now f is given to be a differentiable function. When it is differentiable, both left hand derivative and right hand derivative exist, and they are equal to the derivative of f at x. So they are equal. Right hand derivative is equal to left hand derivative is equal to derivative. Then the inequality 2 becomes f prime x greater than or equal to 1 by x plus 1. Inequality 3 becomes f prime x is less than or equal to 1 by x plus 1. 2 and 3 put together will be f prime x is equal to 1 by x plus 1. So then suppose you substitute f prime of 1 by n square. As n is a positive integer, 1 by n square will be less than 1, greater than 0, and f prime of 1 by n square will be 1 by n square, that is n square plus 1. So now we want the sigma, the summation. So now sigma n is equal to 1 to 20, f prime of 1 by n square will be sigma n is equal to 1 to 20, f prime of 1 by n square is n square plus 1. Right. And now what is this value? We will show you in the adjoining snippet. Sigma n is equal to 1 to 20. Sigma n is equal to 1 to 20 of n square plus 1 is sigma of n square plus sigma of 1. Sigma of 1, n is equal to 1 to 20. 1 plus 1 plus 1, 20 times will give you 20. And sigma n square, n is equal to 1 to 20 will give you, we have a formula, that is n into n plus 1 into 2n plus 1 by 6. That is to be evaluated when n is equal to 20. Right. When n is equal to 20, it will be 20 into 20 plus 1, 21 into 20 into 2 plus 1, 41 by 6. That is 20 into 21 into 41 by 6 plus 20. Simplifying, will get 2870 plus 20, that is 2890. We will go back to this place, and that is equal to 2890. So that is your required answer. So the answer to this question is 2890. That is the detailed discussion of the solution of the given problem. I will say that it is definitely a good question. Now let's move to the next slide. So this question has appeared in the JEE Main exam held on 27 January 2024 in the second shift. The given problem is, let g of x is equal to 3 times f of x by 3 plus f of 3 minus x and f double prime x greater than 0 for all x belongs to the open interval 0 to 3. If g is decreasing in the open interval 0 to alpha and increasing in the open interval alpha comma 3, then 8 times alpha is, we are given 4 options. So now let's discuss the solution of the problem in detail. We are given a function g of x, that is 3 times f of x by 3 plus f of 3 minus x for all x belongs to 0 to 3. Further, it is given f double prime x is greater than 0 for all x belongs to 0 to 3. when f double prime x is greater than 0 for all x belongs to 0 to 3, it means f prime x is an increasing function in the interval 0 to 3. And this fact is required and we will be using in the discussion. Right. Now this question is basically to discuss its increasing and decreasing nature in the interval 0 to 3. So for that, for increasing and decreasing nature, we calculate the first derivative. That is g prime x is equal to f prime of x by 3 minus f prime of 3 minus x. Right. Now, to get the critical points, we put g prime x is equal to 0. That means f prime of x by 3 minus f prime of 3 minus x is equal to 0. That means f prime of x by 3 is equal to f prime of 3 minus x. What is f prime? F prime is an increasing function in 0 to 3. So f prime of x by 3 is equal to f prime of 3 minus x will imply x by 3 is equal to 3 minus x, because f prime x is an increasing function in the interval 0 to 3. And simplifying, we will get x is equal to 9 by 4. That is one critical point we have. And where is this 9 by 4? 0 less than 9 by 4, strictly less than 3. Yes. So let's now continue the discussion in the next slide. And now we got the critical point 9 by 4. We'll discuss now where is it decreasing. For decreasing nature, you have to take g prime x less than 0. This implies g prime x is less than 0 means f prime of x by 3 minus f prime of 3 minus x is less than 0. That will imply f prime of x by 3 less than f prime of 3 minus x. And f prime x is an increasing function. Therefore, it will give you x by 3 less than 3 minus x. So, now simplify, you will get x is less than 9 by 4. So, that means your g of x is a decreasing function in the interval 0 to 9 by 4. Right. Now, where is this function g of x is increasing? For that, consider g prime x greater than 0. That is f prime of x by 3 minus f prime of 3 minus x is greater than 0. That will give you f prime of x by 3 greater than f prime of 3 minus x. But we have f prime x is an increasing function. This will imply x by 3 greater than 3 minus x. And simplify, you will get x greater than 9 by 4. That means our function g of x is an increasing function in 9 by 4 to 3. Because 0 less than 9 by 4 less than 3. So, this is the one. So, thus combining these two, g is decreasing in the open interval 0 to 9 by 4 and increasing in the open interval 9 by 4 to 3. But we are given that g is decreasing in the open interval 0 comma alpha and increasing in the open interval alpha to 3. That means alpha must be equal to 9 by 4. Required to find the value of 8 times alpha. So 8 times alpha is equal to 8 into alpha value 9 by 4. Simplify, you will get 18. So the answer to this question is 18, which appears against option 1. Therefore, the answer is option 1. And that is the detailed discussion of the given problem, and it is also good question. Great. We now move to the next question. This question has appeared in the JEE main exam held on 29 January 2024 in the first shift. The given question is, consider the function f from the closed interval 1 by 2 to 1 into the set of real numbers defined by f of x is equal to 4 root 2x cube minus 3 root 2x minus 1. Right. Consider the following two statements. Statement 1. The curve y is equal to f of x intersects the x-axis exactly at one point. Statement 2. The curve y is equal to f of x intersects the x-axis exactly at x is equal to cos pi by 12. So then we are given four options. Which of them are true? Are both true? Are both false? One of them is true, the other is false. So such kind of routine options are given to us. Right. Let's move to the next slide for the solution. We have the function f from the closed interval 1 by 2 to 1 into r defined by f of x is equal to 4 root 2x cube minus 3 root 2x minus 1. Observe that f of x is a polynomial, is a cubic polynomial. Right. Now, let us check the truth of the statement 1. Let's write down the statement 1. That is the curve y is equal to f of x intersects the x-axis exactly at one point. Right. So first, that means y is equal to f of x has exactly one root. One root in the closed interval half to 1. That's what it means. Right. First note that because you are talking about this curve intersecting the x-axis means f of x has a root. For that, we remember the intermediate value theorem. So first, note that f of x is continuous in the closed interval half to 1. Why? How this is continuous? Because it is a polynomial. We know every polynomial is continuous everywhere. Therefore, f of x is continuous in the given closed interval. Right. Continuity, we got it. Now, we take their values. F of 1 by 2, substitute for x is equal to 1 by 2 and simplify. You will get minus root 2 minus 1, which is negative. Right. F of the other end, that is f of 1 is, for x is equal to 1 you substitute, simplify, you will get root 2 minus 1, which is greater than 0. Thus, f of 1 by 2 and f of 1 has opposite signs. Then, by the intermediate value theorem, the f of x is 0 for at least 1x in this interval. So, the curve y is equal to f of x intersects the x-axis at least at one point. Only this much it says, at least. How do you say? It intersects exactly at one point. For that, we take y is equal to f of x. Is it increasing or decreasing? Let us see. Now, f prime x, calculate. The derivative is 12 root 2 x square minus 3 root 2. And see what is f prime of 1 by 2. That is 0. F prime of 1, substitute here, 9 root 2. And you take any point in between. We have taken exactly the midpoint, that is 3 by 4. F prime of 3 by 4 is 27 root 2 by 4 minus 3 root 2, which is greater than 0. That means to say f prime x is positive, strictly positive for every x in this interval. That means f of x is a strictly increasing function in the given closed interval. And that is the fact 2. The fact 1 is y is equal to f of x intersects the x-axis at least at one point. Now it is strictly increasing. It cuts the x-axis at one point, and it will not cut at any other point because it is strictly increasing. So this fact 1 and 2 put together will tell you that the curve y is equal to f of x intersects the x-axis exactly at one point. Thus, your statement 1 is correct. Right. Let's now move to the next statement. That is the second statement. The curve y is equal to f of x intersects the x-axis exactly at x is equal to cos pi by 12. In the statement 1, we have seen that the equation f of x is equal to 0 has exactly one root in this interval. What is that root? We will show that root is cos pi by 12. Right. So how do we show that? So we take f of x is equal to 0 because we want to talk about the roots. So take the root 2 common. 4x cubed minus 3x is equal to 1. That will give rise to 4x cubed minus 3x is equal to 1 by root 2. Here the weakness is this 4x cubed minus 3x. If you substitute x is equal to cos alpha, this will be 4 cos cube alpha minus 3 cos alpha is precisely cos 3 alpha. So let x is equal to cos alpha, substitute, then it will be cos 3 alpha is equal to 1 by root 2, that is cos pi by 4. That will give rise to 3 alpha is equal to pi by 4 and alpha is pi by 12. That means this shows x is equal to cos pi by 12 is a root of the equation f of x is equal to 0 in this given closed interval. But cos pi by 12 value we know, root 3 plus 1 by 2 root 2. That will give rise to approximately 0.9659, which belongs to half to 1 closed interval. So we have already seen that this equation has exactly one root, and that root is this one, because this lies in this. So that is the curve y is equal to f of x intersects the x-axis at x is equal to cos pi by 12. Thus option 2, the statement 2 is also true. Let's look at our options. Our option 3 says both 1 and 2. The statements both 1 and 2 are correct. Therefore, the answer to this question is option 3. That is the detailed discussion of the solution of the given problem. We now move to the next question. This question has appeared in the JEE Main exam held in 29th January 2024 in the second shift. The given problem is the function f of x is equal to 2 into x, 2x plus 3x to the power of 2 by 3. X belongs to R has, we are given 4 options. F of x has option 1, exactly 2 points of local maxima and exactly 1 point of local minima. Option 2, exactly 1 point of local maxima and exactly 1 point of local minima. Option 3, exactly 1 point of local maxima and no point of local minima. Option 4, exactly 1 point of local minima and no point of local maxima. The question is based on the points of local maxima and local minima, and it will be definitely be very easy. We now discuss the solution of the problem in detail. We have the given function f of x is equal to 2x plus 3x to the power of 2 by 3, where x belongs to R. So to talk about local maxima and local minima, we have to compute its first derivative. Differentiate f of x with respect to x. Differentiated here, you get a 2 plus 2 into x to the power of minus 1 by 3. 2 is taken common. 1 plus 1 by x to the power of 1 by 3. Taken the LCM, you will get 2 into numerator x to the power of 1 by 3 plus 1 by the denominator x to the power of 1 by 3. Now how do you get critical points? The points where f of f prime x is equal to 0. That's 1. That is x to the power of 1 by 3 plus 1 is 0. That is x to the power of 1 by 3 is 1. X to the power of 1 by 3 is minus 1, sorry. That will give you x is equal to minus 1. And f prime x is undefined when x is equal to 0, because x to the power of 1 by 3 is sitting in the denominator. And the critical point is also given by those points at which f of x is not differentiable. So now f prime x is equal to 0 will give you x is equal to minus 1, that is a critical point, and f prime x does not exist at x is equal to 0. Therefore x is equal to 0 is also a critical point. Therefore the critical points of f of x are x is equal to 0 and x is equal to minus 1. Right. Now we have to discuss the local maxima and local minima of the given function. For that, we take the real numbered line. Right. On the real numbered line, now this is the point x is equal to minus 1. This is the point x is equal to 0. Now for any x greater than 0, here, for any x greater than 0, x to the power of 1 by 3, the denominator is 0, is positive. X to the power of 1 by 3 plus 1 is positive for any x greater than 0. Therefore, f prime x will be positive. For any x in between minus 1 to 0, the denominator x to the power of 1 by 3 is negative. The numerator x to the power of 1 by 3 plus 1 is positive. Therefore, f prime x is a negative. Yes, it's negative. And when you take x to the left of minus 1, that means for any x less than minus 1, both numerator and denominator of f prime x are negative. Negative by negative, that is positive. You will get f prime x is positive in this. Right. So what do you observe? We observe that f prime x changes sign from positive to negative as x moves through minus 1. That means f of x increases up to minus 1 and then goes on decreasing there, and thereby x is equal to minus 1 will be a point of local maxima. Right. Case 2. F prime x changes sign from negative to positive as x passes through 0. Right. That means f of x will be from decreasing nature. So that means the point 0 is a point of local minima. This means the point 0 is a point of local minima. So f of x will be goes on decreasing up to x is equal to 0, then increases. So it is a local minima. Right. So that means what is that? The conclusion is that f of x has exactly one point of local maxima and exactly one point of local minima. Let's look at the option 2, and that says exactly one point of local maxima and exactly one point of local minima. Therefore, the answer to this question is option 2. And it is definitely a very easy question. That is the detailed discussion of the solution of this problem. I am sure that you have understood the 4 problems and their solutions, what I have discussed in this video. Please like and share my videos and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.